Bismillahirrahmanirrahim. Good morning, ladies and gentlemen, and welcome to the last session of the Resilience Stream of the GDA International Downstream Conference. In this session, we'll have three presentations by five distinguished speakers: Rakesh, Budithi, and Lulwa Alzayani from Bahrain Petroleum Company, BAPCO, Goutam, Biswas, and Raffaele, Fronteddu. Goutam is from Chevron, CLG, and Raffaele from ENI, and we'll have Bassel, Filfilan from Saudi Aramco. We will kick off our session with the BAPCO presentation, which is titled Innovative Approach for On-Stream Removal of Ammonia Chloride Fouling Prevent Crude Unit Shutdown. In this presentation, which will be co-presented by Rakesh and Lulwa, the speakers will share with us their experience of online chemical cleaning of one of their biggest crude unit and how they prevented costly unit shutdown. But before we start, let me introduce the speakers to you. Rakesh is currently working as a senior process engineer in a crude processing section, technical services department of the Bahrain Petroleum Company, BAPCO. He is responsible for technical support for crude and vacuum distillation units, crude gas recovery unit, kerosene and naphtha rerun section, and vessel breaker unit. Rakesh has a total experience of more than 16 years in the field of refinery, commissioning, operation, and technical support. He has been working in the TSD for the last 6 years and holds a bachelor degree in chemical engineering from Jawaharlal Nehru Technological University of India. Lulwa is an associate senior process engineer working with Rakesh in the same team in the technical services department. She has been working with BAPCO for 1.5 years, providing technical support for the crude processing units, which include all crude and vacuum distillation units, and crude gas recovery unit, kerosene and naphtha rerun, and vessel breaker. Lulwa holds a BEng degree in chemical engineering from University of Birmingham, UK. I believe, Lulwa, you'll kick off the presentation, I believe, right? So if you can start, Lulwa, the floor is yours.
Assalamu alaikum. Good afternoon, everyone, and thank you, Aqeel, for the nice introduction. It's my honor to be here today to give this presentation. So our presentation today will be about one of our success stories in which we managed to avoid shutting down our major crude units by deploying an on-stream chemical cleaning. This chemical cleaning was used to remove the ammonium chloride salt in which we had at the top section of the pre-flush column of that unit. So today, my colleague Rakesh and I will walk you through the main events of this experience, and I hope it inspires all of you. So in today's presentation, we're gonna first look at our refinery background. Then we're gonna deep dive into the unit configuration and arrangement, which is for ACDU and pre-flush column. Then I'll hand over to my colleague Rakesh, in which he'll explain more about the flooding problem we had and the temporary action we took. Then we had a TNI shutdown, and we'll share our findings from there. But then again, the same flooding problem happened. But this time we used the on-stream chemical cleaning, in which we succeed at, and we'll share our results from there. Finally, we'll sum up our concluding remarks, and we'll open the door for your question. Okay, so BAPCO is the only petroleum refinery in Bahrain, and it's owned 100% by the government. BAPCO is considered to be one of the oldest refinery in the region. It was established in 1929, and since its early beginning, it has been recognized as one of the key income contributors to Bahrain economy. The refinery actually started processing crude in 1936 with a refining capacity of only 10,000 barrels per day. And these startup units are still existing in our current configuration, so they've been operating for for 87 years as of now. After several expansion projects, the refining capacity increased up to 267,000 barrels per day. And we're starting exporting our products locally and globally. And we did not stop at this capacity. Currently, we're working on the biggest project ever undertaken by BAPCO, which is called BAPCO Modernization Program, in short, BMP. This will increase our refining capacity up to 380,000 barrels per day. And also we'll be having one of the largest resid hydrocracker units, which will reduce our fuel oil yield further. And also many old units will be decommissioned after this project. So this will help us to improve our energy efficiency and our compliance to the environmental regulation also. Sorry. Okay, so sorry, just. Okay, sorry, just. Okay, so 4ACDU will be retained post-PMP, and it was commissioned in 1949 with a design capacity of only 90,000 barrels per day. And after revamps and modification, the refining capacity increased to 104,000 barrels per day. And it's currently the biggest crude unit we have in our current configuration. So the 4ACDU is an integrated unit, as it has three main columns, which are pre-flash, atmospheric, and vacuum column, as we can see in the picture here. So this is a very recent picture of the refinery. As we can see that the columns are surrounded by scaffolding, and this is because we are currently in the middle of TNI, which happens every 6 years. Also, one more fact about the unit that is worth mentioning is that the unit does not have a desalter. And yes, we do have a very high chloride content in the overhead system, but it's all under our control. 4ACDU produces a very wide range of products, which we will look into in the next slide. So this is a simplified flow diagram of 4ACDU. So first, the crude enters the pre-flash column, which is separating the lighter cut out of the crude. We've got stabilized naphtha coming from this stabilizer, and also we've got MSR coming from the pre-flash column. We're also, from the pre-flash column, we're also producing the HSR, which is routed to the kerosene pool along with the kerosene coming from the atmospheric column. We have three different cuts of diesel, which are light and medium diesel coming from the atmospheric column, and also we've got intermediate diesel coming from the vacuum column. From the vacuum column, we also have the heavy vacuum gas oil and the vacuum residue. So the scope of the presentation will be on the chemical cleaning that we used on the top section of the pre-flash column over there. So the purpose of the pre-flash column is to separate the lighter cuts and the naphtha components out of the crude before routing it to the crude column. And this is achieved through these 30 trays. The chloride content in the overhead sour water is typically high, which ranges between 800 to 1,000 weight ppm. And this is, as I mentioned, this is because we don't have any desalter. So both neutralizing amine and ammonia were injected in the overhead line to maintain the pH between 6.2 to 6.8. And also we have the sour water circulated back to the vapor line as wash water, and this is helping us to reduce the potential of under deposition in that line and overhead condenser. So that was a summary about the unit configuration, condition, and arrangement. And now I'll hand over to my colleague Rakesh, in which he'll speak more about the problem we had and the temporary action we took. Thank you.
Good morning, all of you, once again. First, let me thank Lulwa for such a wonderful introduction to our BAPCO's legacy and about our 4A crude distillation unit. And I'm pretty much sure that that has paved a great platform to all of you listeners to understand and visualize the best or the on-stream chemical cleaning what we have done in our unit. So that will be definitely helpful to visualize. Now let's move on to the main topic of our presentation. Well, on the day of the incident in June 2020, our pre-flash column had suddenly experienced a high sectional pressure drop in the top of the column, and flooding phenomena was very much evident in the top section trays that are from tray 1 to tray 8. Let me take help from the previous slide. So this was the section that from top 1 to 8 we had this high pressure drop issue. And our the top section pressure drop has eventually gone up by more than 3 folds from our normal sectional pressure drop of 1 psi, and top vapor line has gone up to 295, and our top reflex flow has jumped up to 1400 barrels per hour, which was our alarm limit value. Furthermore, there was some disturbance was seen in the overhead section that in our overhead accumulator, and that has continued up to the downstream stabilizer section due to the overwhelmed naphtha production, and which was feeding to our stabilizer column. As an immediate recovery measure, our technical team and operations team had together, we thought of reducing feed rate to sustain the unit operation, and that has helped to minimize the flooding, and basically that has reduced the load in the top section. As we are all aware, and those were the days of the whole world was hit by COVID, and especially oil industry was also seen that hardship. This crude and product prices were so volatile, and the market was changing was so dynamic, and BAPCO was also not exceptional to that. So therefore, there was a need to keep our assets reliable and ready to face any kind of a demand which comes from the market. So, having said that, there was shutting down of the unit was not economical to troubleshoot or to do any kind of maintenance activities. Therefore, our process team had devised a scheme to route part of our total reflex demand from the top of the column to the tray 5. So we have made up, we have provisioned a jump over line all the way from the top reflex line to the to the tray 5 on the run using hot tub method. There is a little background for why we had chosen tray 5, that we have done process simulation, and also using our general experience that usually the crude columns are much prone to having fouling in the top section of the trays, usually between the top tray to the tray up to 3-4. And one more thing, that we have one additional stream which is coming to the unit, to the pre-flash column from the this is a whole straight run which is coming from the other units. It is basically a normally no flow. So as and when required, we were using this one. And there is one distributor also inside, just above the tray 5 here. So these two things basically are simulation, and having this provision has helped us to have a jump over line from top reflex line to the tray 5. Well, soon after establishing the top jump over flow, the pressure drop issue has alleviated, and flooding was minimized, and that has basically given scope for increasing our feed rate. Well, subsequently, the unit has undergone a planned T&I shutdown in October 2020. And during our inspections, we have found a severe fouling in the top tray downcomers. Actually, this tray has 2 downcomers, and both the downcomers were completely fouled. As you can see from the photographs, that those scales were so huge, and they are very hard in nature. And we had to literally, chip down all those fouling materials. So this fouling in the downcomber had actually reduced the clearance between the downcomber and the tray below, and lead to liquid backup over the tray and resulted in the high sectional pressure drop. The fouling deposits were analyzed and proved to be ammonium chloride salts. During the shutdown, the column was cleaned up and ensured that there is any fouling was left over there. And soon after we start up, we observed that pressure drop has become normal as like our startup run, and it was healthy. So basically, this was our first part of the success story, that we could be able to sustain our unit run and continue to basically run up to our planned shutdown of October 2020. So basically, we have sustained the unit run without an unplanned shutdown for 3 months, from June to October. Well, just after a few months of steady operation, the flooding issue has reoccurred in July 2021 without any prior indication. And this time our pressure drop has increased up to 2.5 psi. As a customary measure, we have immediately reduced our feed rate, and we re-established the reflex jump over. And that has helped to increase our feed rate to some extent. However, we could not maximize the feed rate. Here you may be wondering that why our reflex jump over did not work in this case, unlike previously. So there is a reason for that. As you might be observed, that the first incident has happened in June, and this has happened in July. And as you very well aware, that in this region we have a peak high temperatures in the month of July. So that has basically forced our top reflex temperature on a higher side compared to the previous time. So we could not able to alleviate the flooding issue completely. Various ways were explored by our technical team So various ways were explored by our process team to maximize the feed rate. And one of such measure was to reduce the coil outlet temperature of the heater. But that has led to MSR, LSR yields decrease. So in a quest to maximize the feed rate. Hence, it was not an optimum operation, obviously, because we had to fire hard in the downstream sections to recover the loss yields from the pre-flash column. And it was same again as we were continuing in the COVID hardship, that an unplanned unit shutdown was not at all economical to BAPCO, and it was not affordable, and therefore there was a need to eliminate the fouling on the run. Well, this time our process team has looked at various options, and we just checked with all our networks within the region. And since the fouling was due to ammonium chloride, as it was evident from our last outage, that therefore we checked with different suppliers, and we had able to successfully find a potentially suitable chemical to remove the salts online. The BAPCO team has worked up to make provisions on a war food basis. Just within 1 month, we have just made all the setup, and we have made a provision into the top reflex line to inject the chemical. As soon as we started the chemical injection, within few hours, we started seeing the benefits as the sectional pressure drop has started reducing. And to second that, the neutralizing ammonia, what we are dosing, the demand of the ammonia has started coming down. This is because of, as part of the chemical reaction, the ammonia will be liberated from the salts, and that will be basically taking load of the fresh chlorides which are coming from the crude. So therefore, we able to close the ammonia dosing completely at the towards end of the trial. Well, to summarize on the results, our operating conditions, as I said before, that we have returned to normal. We have normalized our coil out temperature, and therefore LSR, MSR yields were normalized. As a result of successful online chemical treatment, we could able to close the jump overflow completely, and our top reflex flow has normalized to our 1400,000 from 642,000 barrels per hour. And the best part is the top section pressure drop has decreased to 1.4 psi and was stable, and there was no sign of any flooding further. This slide basically outlines about our conclusion on this trial, that on-stream chemical cleaning was a great success, as the ammonium chloride salt deposits were removed from the tray down comers successfully. And this would be for the first time in BAPCO's history to deploy a chemical to clean the, to remove the overhead salts. And this has definitely avoided a costly unplanned shutdown. Indeed, it's not one, 2 times we have avoided. This is regarded to be innovative approach to troubleshoot the overhead fouling issues in the crude pre-flash section. And lastly, the post-cleaning, the unit has been running well since, and there was no sign of flooding, and there was no any indication of high pressure in the top section. And this slide outlines the key factors has helped to achieve this success. That BAPCO, we all have our, we all strive for the operation excellence, right? BAPCO has also follows and delivers operational excellence and business resilience by a systematic approach towards personal safety, process safety, reliability, efficiency, and environmental performance. To achieve such performance improvement, it is ought to possess technically strong in-house team to always, look for the opportunities and, to improve the reliability of the system. It is also important to have, paying attention to the detail, as significant gains can be achieved from the remote opportunities. It is also important to have a strong networking within the industry, and having knowing new advancement within the business that will help us to improve our systems. And of course, lastly, a close collaboration between the multidisciplinary teams is also very much important, and between the chemical supplier as well. As I said before, the whole team has worked shoulder to shoulder relentlessly towards one goal, to improve the reliability of our unit. So lastly, always strive to improve and develop and improve in-house expertise and know-how, as no one will look after your business better than you do. With that, it brings us to the end of our presentation. Thank you so much for being here and listening to us. Hope to see you all again, inshallah.
Thank you, Lulwa and Rakesh, for the excellent presentation. Now we'll go to the second presentation. Rakesh. Okay. We'll go to the second presentation, which will be co-presented by Goutam Biswas from CLG and Raffaele Fronteddu from ENI. Goutam is responsible for slurry hydrocracking development and jointly leads the technical team for CLG Alliance with ENI for developing enhanced slurry technologies. He derives Chevron downstream on refining and chemical growth strategies, midstream value chain and long-range strategies planning, and is a member of India's strategies team. Sorry, Goutam, I'll skip that second part only because of the time. Raffaele Fronteddu is currently licensing commercial manager in the licensing department of ENI. He joined ENI in 2006 as a process engineer and served in several positions in petroleum technology development projects and other energy-related subjects. He holds a Master of Science degree in Chemical Engineering and Master of Business Administration degree. Okay, Goutam, the floor is yours.
Thank you very much. Our topic is going to be low carbon energy hub and future of residue processing. So this is our agenda. I'm not going to go through details, but first we'll talk a little bit more about the CLG and ENI alliance, and then I think we'll be showcasing one of the technologies that the alliance offers is the S technology, and then we'll go into the other part of the presentation. So in 2021, September, CLG, that is Chevron Lummus Global, and ENI of Italy, we signed an agreement for joint cooperation of licensing hydrocracking technologies, that is in the resid sector, mostly from the CLG side, LC fining, LC max, LC slurry, LC LSFO. As you know, CLG is one of the leading licensor of any of the resid processing technologies, like be it coker, be it RDS, or be it our LC platform. And in BAPCO, of course, part of BMP, they have our LC fining that's being built right now. Similarly, on the ENI side, they have been very successful in commercializing the slurry technology. And in fact, currently 3 of the units are running as well, and Raffaele will share more details about that. And this alliance was made to make sure we are able to offer the whole suite of resid technologies to our potential clients. And we are investing, significant amount of money and resources in R&D to improve the slurry process, as well as come up with a catalyst that's going to reduce the cost of operation for our licenses. Next, I wanted to talk a little bit more about the product and petrochemicals outlook, and also decarbonization, how that's going to impact the future investments. I think last couple of days we heard, particularly from the S&P Global, that there is going to be demand destruction, particularly in the transportation fuel sector like gasoline and diesel. And so refineries have to adapt to future where there is going to be sufficient demand in other products, like there will be demand in jet. And we'll talk about, you heard the biofuel, that's one area, and we'll talk here too. But there is also going to be demand in naphtha, and main reason is there is significant demand for plastics or chemicals that's almost going to be doubled in next 2 decades or so. In fact, about 10 million barrels per day of additional hydrocarbon liquid will be needed to supply to the petrochemical sectors. While refineries will adjust operation to produce naphtha or maybe hydrotreated gas oil to feed to petrochemicals, there is still going to be about 4 million barrels per day of shortage. And those 4 million barrels per day of additional feedstock will mostly come from crude, some of it directly crude to chemicals, but that will have resid processing unit. Others will come traditional refining processes, will go through more traditional hydrocracking, where you might have diesel hydrocracker or VGO hydrocracker, but there also you will have resid hydrocracker. And so we'll be talking, or Raffaele will be talking about how EST unit fits into producing either transportation fuel or petrochemical feedstock. And then I'll share how you can upgrade in the same unit. And then also we'll talk about biofuels, which after that session. Go ahead, Raffaele. So, in last 2 days, we heard a lot about decarbonization and how that is having impact in our industry. There is one thing that we are always finding out, that investment has dried up in our industry because of the decarbonization. And if any investment, including what is happening in Gulf countries, they want capital efficiency, they want energy efficiency, because in future they want to produce minimum or no emissions or greenhouse gas emissions. So this is where I think our technology comes into picture. One thing is, how do you reduce the capital cost and how do you have better energy efficiency, is if you can process the product that you generate in, let's say, ST unit or LC fining unit. If you can upgrade in the same high pressure loop, which is typically 2/3 or 3/4 of the cost for a hydrocracker or hydrotreater, you can significantly reduce the cost of the unit. At the same time, because you are using the same high pressure gas that's coming from the resid hydrocracker, you reduce also the energy input into the unit. So this was first done for our Shell Canada unit in Edmonton. And since then, we also had a 2-stage hydrocracker that was built at Neste. So this is well proven, and it has been, all those units are running. So the same thing we are going to incorporate in ST unit, where we'll be taking the experience from LC fining integrated hydroprocessing for product upgrade to the ST unit, where we'll put in the same high pressure loop fixed bed reactor to upgrade the product. In that process, not only you are reducing the capex, you are also reducing the energy input. So that will be creating less emissions. The other thing is, every investment that is happening today, one question is being asked, is that going to be used for future? Like if future, even in Gulf countries, looking at processing biofuels or waste from municipalities, etc., can you utilize existing assets or assets that you are going to build that you can process this type of product? And our technologies like EST, LC fining, they can take feedstock like from the circular feedstock or bio feedstock, and they'll be able to process that. You want to go? Okay. So in case of circular feedstock, you can take the pyrolysis oil from the plastics, or you have the right type of plastic material, you can make that into fine solids, and you can co-feed with other feedstock like VR in our resid hydrocracker unit, and you can upgrade to products, either feed it to the petrochemical unit after hydrotreating, or you can make transportation fuel. So this is our renewables feed processing scheme. This is the conventional LC fining that we are shown here. In many cases, like if you have good quality feedstock, particularly like vegetable oil, you can use something like CLG's Isoterra process, which is a fixed bed unit, where you can produce something like 90% SAF, sustainable aviation fuel, or 100% renewable diesels from there, but not all feed is clean. So if you have a dirty feed, or if you have feeds like pyrolysis oil from the wood-based stock or lignin, you can either co-feed or you can 100% feed it to LC fining type of unit and convert that to valuable bio products like renewable diesels or renewable jets. So this is the flow scheme for that. I'm not going into detail because we have time limitation. So key takeaways from our presentation is, the technology that we are offering is not only for today. But tomorrow, if you want to process alternate feedstock, they will be suitable for that. And this will be energy efficient, this will be capital efficient, and it's already being used in our in BAPCO, in LC fining unit. You want to add something to ST? And maybe I'll add one more thing, that there has been tremendous success in our EST licensing. There are 3 units operating. There is after we formed the alliance, our first license was signed last year. And I think one of the owners, ZPC, is signing a 3rd unit. So there's a lot of experience being built into that. So we'll be, if you have any question related to that, we'll be happy to answer later on. Thank you.
Okay, we'll start the question answer session now. Any question? Okay.
Assalamu alaikum, this is Raffaele from Saudi Aramco. Thank you for all the speakers, clear forward presentations. My question for CLG is, ENI is, what's the applications of converged stream? As mentioned, the converged is 97%. So there is a 3% which is the converged stream. So what's the application have been considered for this stream? Also for Bassel, the question is, why we did not consider to use non-metallic material instead of the alloy 20? Thank you.
Okay, I can take the first question. So in our refinery in Italy, our EST unit, the purge that is produced is sell as a fuel oil to cement factory, which is 300 kilometers far from the refinery. In China, Sinopec has so before installing the EST, they had 2 coking trains. One of the 2 has been shut off and replaced by EST. The coking train remained, received the purge from EST, so they are co-feeding the purge to the existing coking. Okay, and ZPC, they installed a dedicated gasification unit. So that's, I would say, personally think the best option, since with this they also recover the molybdenum as oxide and close the circle. So also for the catalyst, that's a good option. Okay.
Yes, with regard to the use of non-metallic, it was considered, actually the non-metallic is very good option to avoid the corrosion cases. However, due to the time limitation, or because we needed the system to be running as fast as possible, and we didn't have the sources for the non-metallic immediately, so we elected to go with the available alloy 20. Again, the system was already alloy 20 for the piping. Only the fitting material was not alloy 20, which was Incloy 800. We also considered to have a carbon steel lined with BTFE, but due to the increase in size of the diameter or the thickness for the pipe, we couldn't implement that change.
Okay, thank you, Bassel. Any other question?
Yes, please. Okay, Assalamu alaikum. Sam from Saudi Aramco and hydrocarbon processing as well. Okay, regarding what I mentioned in the presentation for the CLG, okay, it was very nice. It was well for me. It's wonderful invention, okay, and in the industrial technology, regarding especially for the hydrocarbon factories. Okay, but the question here, that's what I'm asking. Okay, we know that all of us, okay, there's what a purely difference between the FCC and also the hydrocarbon. The side effect, okay, of the FCC, we know that there is some slurry, and here there is no any slurry at all. Why? Because due to the thermal decomposition, that will not be impacted later on in the final product. Okay, but my question is, right now, the catalyst. Let us get start our imagination to let the catalyst to be injected. Am I right? And then that means the catalyst to be what injected all the time. Okay?
Yes.
So that means to be what in patches every day, to every hour or in
It's a continuous makeup of the precursor
Okay.
and a continuous purge. So it's continuous process.
It's continuous process.
Yes.
Okay, because I thought that what it should be like the CCR, like things. Okay, it should be what a regenerator or something like that. That's what I thought about it.
Okay. So at the startup, you
Because when you
accumulate.
we face with the fixed bed.
Okay, it's a different concept respect of a fixed bed, because you do not have a volume of catalyst.
Okay.
But at the startup, you just increase the concentration of the molybdenum until a certain threshold, and then from that moment on, you open the purge and you start making up. So that's a balance to have more or less the same concentration of molybdenum inside the reactor.
But here, mainly, if you are looking for the growth for the naphtha and jet fuel product, but for the aldolose of the diesel, it doesn't work.
Can you please repeat?
Okay, if you are looking for to increase your throughput for the aldolose of the diesel, mainly for the diesel, or for the mid distillates for the diesel, this kind of technology, it will not be compatible with.
So it's a different concept, because in EST the first initiator is thermal. So you crack and then hydrogenate. If you want more naphtha, you increase the temperature. You will produce more naphtha simply because you crack more.
Yeah, you say completely right. But to be honest with you, but because we're here, it's similar like what the FCC.
Yeah, so it's different. It's different.
Another section.
Raffaele.
Another question.
Maybe after the.
Okay.
Let's give the chance to that.
Let me respond to that question a little bit, if you don't mind. Aqeel?
Go ahead.
Aqeel, can I close it?
Okay.
So if you want to increase your naphtha or diesel production, you want, because you'll be producing a lot more VGO, you'll be processing that in the fixed bed downstream, just like conventional hydrocracker.
Yeah, to manipulate with the temperature profile. I know. So one last question. For
Please, let's give the chance to the others. Maybe after the session, you can ask the question, please, okay? Sorry for this, but...
For Rakesh, what type of chemical that you use for the chemical washing?
Well, I was expecting this question, but due to our IP and non-disclosure agreement, we could not share much of the details on the chemical at this point of time. But it's basically a salt dispersant chemical, which is basically an amine-based chemical.
With a percentage of water?
Sorry?
Is it okay to share the trade name?
Is it diluted in water, or it's just only pure amine?
No. It having some. It's amine-based one with the tall oils. Yeah, that's what I remember. Honestly, yeah. But it's not pure amine. It's a base of the amine, but with the mixer with the tall oils and others.
Is it acceptable to share the trade name? Maybe the gentleman can obtain detail from the supplier.
I'm just curious, because ammonium chloride is soluble in water. Sometimes you can use water and dissolve it in water.
Yeah, if you just allow me to answer on that one. As I said, our team has explored various options. Part of that one, the first thing has come to have a water wash at the top of the column. However, as Lulwa has mentioned, this is a very old column, and we have very, kind of a very old internals and all. So we don't want to take a chance to have a, kind of a catastrophic event or anything if you use water washing. So we just avoided for that particular, So.
Okay. Well, okay, we have time for 2 more questions, but please make them short, if possible, please.
Yeah. My question is for colleagues from BAPCO. My understanding is that the source of ammonia for this ammonium chloride in the overhead of the column, in the top of the column, is the ammonia that you are injecting, or is there any other source of ammonia in the system?
Well, as you rightly mentioned, yeah, this is the source of ammonia is mainly from the ammonia what we are injecting at the top of the column. Because we have checked, get our crude analyzed at different facilities. We do not have any kind of a tramp amines or any kind of other amines. So it's purely from the.
Did you try to eliminate the ammonia since you are injecting already another neutralizer in the system? And to eliminate the injection of ammonia, which is not very efficient for the overhead system protection, is creating also this kind of problems of plugging. Thank you.
Maybe I'll allow Lulwa to answer that one. And we have actually answered, so I'll give a chance to her to answer.
Okay, so as I mentioned in my slide, initially we were only using ammonia, and then we added neutralizing amine, which is having a lower salt point, which would help us to control that high chloride content that we have. But and yeah, we did some operational changes to like reduce the overhead temperature, for example, and stuff. But we had we did not succeed at that, and then we find the ammonium chloride salt, and we had to do the downstream chemical injection.
Just to chip in, what she's trying to say that we look for an alternative option to have a commercial amine, but as we said, we have a huge load of chlorides in the overhead. The cost was exorbitant, and the budget wasn't allowed to, have 100% amine for neutralization. So we made interim this one an option to have 30% and 70%. That also we tried, but as you rightly mentioned, we at this point of time we could not able to completely avoid the ammonia injection. We have to continue to have this one.
Yeah, thanks. Okay. One more question. We have the time. Let's try and see others. No, just after the session, maybe we can have a discussion with the guys and get more details.
Thank you all speakers. It was really great presentations. My question to Chevron team, I believe for the AST units, it's already commercialized, right? And my second question is how much you are expecting the catalyst lifetime, and is it suitable for all the residue, even for heavy and medium, or which type of crude you are targeting? Thank you.
Go ahead.
Okay. So yes, it is commercialized. Of course, we have approximately 10 million ton per year of operating capacity. Actually, the lifetime of the catalyst, unfortunately, so even when we purge the catalyst is still active. It's just that for the moment we are studying it together with CLG, the way to recover the molybdenum, or to have a different catalyst, similar catalyst, but with different characteristics, to improve the lifetime of this catalyst. So not to purge it, but to recycle in another way. The last question is about the quality of the feedstock. I can say any kind of feedstock. We tested from Canadian oil sands tar, visbroken tar, extra heavy oil crude from Maya to Venezuelan. I would say any kind.
This is the last question. عشان لا تسأل. Okay.
Thanks so much.
I'll give him the mic. No, that's okay. No, this will be the last question. Okay.
The question for Bassel. Okay, that's all, please. Thank you so much. I appreciate it. Bassel, regarding for your presentation, it was very good, and also it was was nice, that's what I'm finishing as well. That's what seemed to me. But also the other side, you mentioned what during the engineering assessment and the other thing, also it was concluded, and also there were some recommendations were implemented accordingly. But the question here, what you faced or experienced a lot of repeated corrosions that you already mentioned that in the summary, the last part.
Okay. Can you repeat? Sorry again.
Okay. The assessment, it was concluded, am I right? And also the way some recommendations were implemented accordingly. That you mentioned that during your presentation. But why the system, it has been faced, still were faced, okay, some repeated corrosions.
Okay, so after we completed the assessment, after the initial incident that we faced, we had a set of recommendation. However, the recommendation will take long time to completely implement. And I think this is what you mean when what happened is we started implementing in phases. We could not complete the whole recommendation in one shot. So that's why we were faced with many other concerns or challenges. However, it was not as severe as the first one. I hope this answers your question. Thank you.
Okay, thank you. The speakers will be around, so if anybody has any question to ask, they will be around and they will be available to answer your questions. And so this is the end of our sessions.